Hello all and welcome to this video. Today I'll be talking about quadratic equations. In engineering and sciences, including technology, we do encounter equations that are of the form ax squared plus bx plus c is equal to 0. So the aim of solving such an equation is to find the values of x that satisfies the equation. So in other words, we want the aim is to find a situation where the left hand side of that equation is equal to the right hand side of that equation. So to solve this equation, we need to understand some terminologies, right? So first, the equation is pretty much divided into three parts. The first part, which is the ax squared, is pretty much what we call the quadratic part. So it's so just indicate the quadratic path of the equation. The second part, which is the bx, is pretty much the linear part of the equation. And finally, you have the final part, the third part, which is pretty much what we call the constant term. So there are lots of applications of quadratic equations. Just to highlight some of them, let's look at the applications just briefly. So especially we'll focus on engineering. For example, we may have what we call in engineering, again, if you're not up to this level, don't bother about it for now. You're going to see that later in engineering. We may have what we call differential equations. In engineering, and we have lots of them. So we could have an equation of the form, for example, d squared x over dt squared plus b dx over dt plus c is equal to 0. So this is typically in a mechanical system where you have a little bit of vibration, right? So you could have that situation where you have that. So this has to be transformed. This could be transformed to something that looks like this, like a quadratic equation m. You could have a situation where this becomes x squared plus bx plus c is equal to 0. And if you compare that with the previous equation, so if you compare these two equations, you will see that they have that similarity, right? We could also have electrical circuits, right? So electrical circuits that pretty much would appear in the form of, for example, 10i squared plus maybe 5i plus 6 is equal to 0. So I here, pretty much I here indicates the current passing through the circuit, right? So you could have that situation. So in areas like, again, for example, civil engineering, you could have a situation where you're trying to design a highway, right? So a highway that goes that way. So again, you could now have your vehicles passing through that highway, something like that. So through that highway. So again, you can see that this is pretty much what we call a parabola. And when we talk about parabolas, we're talking about it represented in the form ax squared plus bx plus c is equal to 0. So you can see that this has lots of applications in engineering, right? So this is just a few of them that I can just pretty much highlight, right? So now let's now focus a little bit more on how we can actually solve such equations, right? So let's start off now with looking at the methods, right? So the methods to solve such quadratic equations, right? So the methods we can use, so methods used to solve quadratic equations. And we're going to focus on a few of them. One of them, the first one, is we could use the factoring method. Two, we could use the quadratic formula. Three, we could use a method called the completing the square method, right? And four, we could use a graphical method as well. So we're going to look at the factoring method, which is very straightforward. We're going to look at the quadratic formula. The completing the square method is kind of related to the factoring method, and the completing the square method was used to derive the quadratic formula. So we will not focus on this one, but we would also talk about the graphical method as well in a separate video, right? So for now, we want to focus on this video on looking at the factoring method, which is the first method, right, to solve such quadratic equation. Let's look at the factoring method now. Let's look at the factoring method. So in the factoring method, the main aim there is to find the factors of any particular quadratic equation, right? So so if you look at it, so let's just, it's clearer when we look at an example. So let's take an example, example one now. We'll just take a very simple example and look at it. So if you have an equation x squared minus 9, 9x is equal to 0. If you look at this equation, if we try to compare this, right, to the original form of a quadratic equation, remember a quadratic equation has the form. So a quadratic equation is of the form ax squared plus bx plus c is equal to 0. So if you compare this and that equation, you will see that my a in this case is equal to 1, because there's nothing attached to the x squared here. You will see that my b in this case, just what the coefficient of x here is minus 9, and of course my c is equal to 0 because I don't have any constant term attached in that equation, right? So if you look at that, right, we can do something. Let's find the factors of that equation, right? So if we factorize the equation above, you would see that the factors that we can get is going to be x into x minus 9, right? Is equal to 0. Again, if you multiply x into that bracket, you get x times x is going to give you x squared, which we have here, and x times minus 9 is going to give you minus 9x, right? So these are the factors of that equation. So in other words, if you look at that, it's almost similar to saying, okay, well, x times y is equal to 0. What this implies is that it's either, therefore, either x is equal to 0, or you can say y itself is equal to 0, right? So similarly, if we apply the same principle here, that means it's either we have x equal to 0, or we have x minus 9 is equal to 0, in which case my x now becomes equal to 9 on that one. So that means the solution to the equation. So if we look at the solution to this problem is x is either 0, and you could have x equal to 9. So again, as I always advocate in all my videos, the best way to do this is you could try to see if you can quickly test it out, right? Check if the values you just got for x is correct, right? We can do that very quickly. So let me just take this. So if let me just, okay. So if I go in here and I can quickly check. So let's do a very quick check to see if this works. So if I substitute x equal to 0 into that equation, let's see what we get. We're going to have 0 squared minus 9 times 0. Of course, this is going to be 0 because, again, you can see clearly that this means that my left hand side is equal to my right hand side. So that is satisfied. Let's substitute now the second part of this. We put in x equal to 9 and see what happens there, right? Into that original equation. Remember, this is the equation we're talking about here, right? So if you put that, what are we going to get? Let's see. So we're going to get, if we substitute x equal to 9, we're going to get 9 squared minus 9 times 9. Let's see if that is equal to 0. Of course, if you do that, you're going to get 81 minus 81, which is of course 0. Again, it confirms that the left hand side of the equation is equal to the right hand side of the equation. Okay, this seems a little bit easy. Let's see if we can take a second example now, right, to really find out if this method is kind of, it works for several types of quadratic equation. Let's look at example 2 now, right? Let's look at the second example now, right? So if we look at the second example, we want to try something different, right? Let's say we have, for example, let's say we have x squared plus 2x plus 1 is equal to 0. Let's see if we can solve this problem, right? When you look at this, it's a little bit complicated. So always remember that quadratic equations, are of the form, we can represent this equation of the form, x squared plus sum of the roots of the equation. So remember, the solutions of the equations that kind of like you're looking at the roots of the equation, right? X plus the product, right, is equal to 0. So remember this, the position where we have the sum of the roots, that's our b value, and where you have the product, that's our c value, right? So if you look at this equation and compare this, you would see that, of course, just by comparing this equation, you would see that my a here is equal to 1, my b is equal to 2, right? And my c in this case is equal to 1. Again, what have I just done? I've compared this with the form of the quadratic equation. So what I just did was to compare this with the form of the quadratic equation. So ax squared plus bx plus c. You can see where the coefficient of x squared is supposed to be a, and that is occupied by nothing. So that's 1. A is equal to 1. The coefficient of b is pretty much the coefficient of the coefficient of the x is actually my b value, and of course that's equal to 2. And then finally you have the constant term, which is actually plus 1. Okay, good. So if we look at that now, we can see, the big question there is to ask ourselves, okay, what are two numbers when you multiply them together, they give us plus 1, right? And when you sum them together, they give us 2, right? What are those two numbers? Clearly the numbers should be plus 1 and plus 1, right? So if you multiply 1 by 1, of course you're getting a plus 1. if you add these two numbers, so 1 plus 1 should give us 2, which is actually the b value, and that's the sum of the roots there, right? So that means we can kind of simplify this equation, or we can kind of represent this equation. Let me put it that way. We can express this equation, the equation as a product of its factors or roots now in this case. So again, we can now say this is going to be x plus 1, right, which the plus 1 is actually coming in here, and then you have again x plus 1, right, is equal to 0. If you want to try it out, it's easy to check if this is going to give us back this equation. Let's try that and see. So let's see, if we want to multiply and open up the brackets, we're going to have x into x plus 1 into x plus 1, right? So we use this first term to multiply the second bracket. We use the second term to multiply again the second bracket. So if we do that, what do we get? Let's see what we get. So if you do that, you should get x squared plus x plus x plus 1. So that should give us x squared plus 2x plus 1, which is exactly the equation we have here. All right, excellent. Now that we've done this, right, so we're sure of this now. So how do we now solve this problem? Remember, this is where we were, right? We just proved that we could get back the original equation. So if we look at this, we should say, oh, well, it's almost again like as if you're saying x times y is equal to 0. So that means we can say, okay, well, based on that principle, it's either x is equal to 0 or y is equal to 0, right? So again, if we do the same thing here, we should have x plus 1 is equal to 0. It's either x plus 1 is equal to 0 or x plus 1 is equal to 0, which is the same thing. So therefore, my x should be equal to minus 1. So that's the solution to this problem. Again, you can easily verify that this is the case, right? How do we verify? Again, we substitute the value of this into the original equation and see if that corrects, that makes sense, right? If the left hand side is equal to the right hand side. And if we do that, we should be having minus, so let's do the check now. So we should be having minus 1 squared plus 2 times minus 1 plus 1. So if we do that correctly, again, this has a bracket here, right? So this is going to be 1 minus 2 plus 1. So clearly this is going to give us 0, which proves that that is the solution to that equation, that quadratic equation. Okay, good. So we can have another form, right, of this equation. Let's look at a third example this time around, right? Let's see what the third example would look like. So I'll just clear this. So let's look at example. So okay, so let me just clear this. So let's look at example 3 now. Right? What if you have a situation where now we have 2x squared plus 4x plus 2 is equal to 0? This introduces a problem, right? We've never seen this one. Okay, so let's represent the form of a quadratic equation. Of course, it's ax squared plus bx plus c is equal to 0. So that means, again, you can see where I have my x squared, my a should be equal to 2, right? And my b should be equal to 4. I'm just doing a direct comparison. And my c is equal to 2. Okay, very good. So what do we do in this situation? It's very easy. If you look at this equation, the best way to do it is just to divide the original equation by the coefficient of x squared. Coefficient of x squared. So if we do that, we're going to have 2x squared divided by 2 plus 4x divided by 2 plus 2 divided by 2. Of course, 0 divided by anything should give you 0 there, right? So then clearly this is going to be x squared plus 2x plus 1, which is equal to 0. Now, if you remember correctly, this is kind of similar to our original, the equation we had in example 2. So again, if you want to solve this problem, you find two numbers, right? When you multiply them, you get plus 2. When you sum them up, you get plus 2, and when you multiply them, you get plus 1, right? So those two numbers, of course, should be clearly plus 1 and plus 1, right? So if we do that, we should be having again x plus 1. X plus 1 is equal to 0, right? So again, therefore, x would be equal to minus 1, as we did in the previous example. So again, this proves that this works, right? So again, let's take one more example. This time around, we'll introduce a negative sign somewhere, right? So let's see one more example now in this case. So let's look at example 4 now, right? So let's say we have an equation like this: x squared minus 5x plus 6 is equal to 0. Again, let's bring our equation, the normal form of a quadratic equation: bx plus c is equal to 0. You can see clearly that my a in this case is going to be 1, my b is going to be minus 5, and my c is going to be, okay, this is actually 6. My b is going to be 6, right? Okay, that's good. So again, what's our aim here? Remember, the aim, we always have the equation of the form. We have x squared minus plus sum of the roots, or sum of the factors, if you want to look at it that way, x plus the product, right, is equal to 0. So if we do that, let's look at that now, right? So what are two numbers? When you multiply them together, they should give you 6. And when you sum them up together, they should give you minus 5. Of course, clearly, it's going to be minus 2 and minus 3. So again, clearly, if you do that, you should have x squared plus, if we're summing the roots, it's going to be minus 2 minus 3. X plus the product is going to be what? So it's going to be minus 2 times minus 3. Of course, that's going to give us, clearly, this is going to be x squared minus 5x plus 6, right? Which is the original equation, right? Okay, good. So now that we have this, right? So minus 2 and minus 3. So we can now put them in the form where we're multiplying those two factors, right? So we're going to have x minus 2, x minus 3 is equal to 0, right? Again, if you multiply through and open up the bracket, you'll see that you get the original equation. But let's just go by, okay, well, we already have this, right? So let's see, what is it going to be? So we can have a situation where we say, okay, well, it's either x minus 2 is equal to 0. So in this case, my x is going to be equal to 2. Or you can have a situation where x minus 3 is going to be equal to 0. Therefore, my x is going to be 3. So that means the solution to this equation is either x is equal to 2 or x is equal to 3, right? So that's the solution to this problem. Okay, so again, I always advocate to check if this is correct. So how do you check? Again, substitute these values into the original equation and see if it works, right? So what do we do? So let's put in the value of x as 2, right? So if you check that, let's see if the right hand side is equal to the left hand side. So that's going to be 2 squared minus 5 times 2, right, plus 6. Let's see if we get the same thing. So this is going to be 4 minus 10 plus 6. So this is going to give us minus 6 plus 6. Of course, this is 0. So that satisfies that equation. We can do the same check as well when, again, this is for x equal to 2. We could do the same check when x is equal to 3 and see what happens, right? So we're going to get 3 squared, right, minus 5 times 3, right, plus 6, right? So that's going to give us 9 minus 15 plus 6. So clearly this is going to give me, if I group the 6 and 9, I'm going to get the 15 minus 15, right? So that's going to give me a 0. So that's for sure correct. Okay. So this kind of explains the factoring method, right? To solving quadratic equation. Quadratic equations, as I mentioned before, appear in a lot of things in engineering and technology, right? So it's very, very important that you understand how to solve quadratic equations. And as you've seen now in this video, it's very straightforward. Okay, thank you very much for watching, and I'll see you in the next one. Bye.